All right. Hello, everybody. Yes, that one is live. I'm just going to change some things. Hello. Hi, everyone. Thank you so much for joining. Oop, that's not the right banner. We're just going to wait a couple more minutes for more people to hop in, and then we are going to get started. How is everyone's day going so far? I am in Central Time, so right now I can see it's still a little sunny out, but I'd love to hear how things are going on your guys' end. I hide that. There we go. Yes, I saw that. I did not make it to the keynote earlier today. I had no idea that we did the video, but I didn't know that they were going to announce it or anything today, and so that was really cool to see it. So yeah, thank you so much for watching. That was really fun to do. Yes, hello. Oh no, I'm so sorry that you have COVID. It's always kind of weird here because I feel like we're so not late in the game when we're thinking about, oh my gosh, we're in a pandemic. And so I hear people have COVID and I'm like, oh my gosh, but I'm really sorry about that. I know that's not ideal at all. A little bit rainy. Okay, I see 2:30. Oh my gosh, just committed. 2:30 a.m. Yeah, it's like 4 o'clock p.m. my time. So yes, thank you so much. 2:30. Hello. Yes, we'll wait one more minute and then we're going to kick it off. So just getting everything ready to go. I saw some of the comments from the previous session, machine learning. That sounded really cool. Did any of you guys go on to that one before this? Hello. Yes, I heard. Yes, I know Will was running that one. I heard amazing things. I didn't get to see it because I was preparing for this one, but I'm super excited. All right, it is past the 5-minute mark for my time, so we're going to get started. Hello, everyone. Nice to meet you all. My name is Governess. You may not have seen me before running these streams because this is my first ever stream with MLH. This is my first anything with MLH. I just recently joined the team about couple weeks ago maybe, and so I saw this opportunity to hop on live streams and being able to interact with you guys, and I was like, okay, I don't know what I'm doing, but I gotta hop on that right now. So I'm super stoked to be here to see you all, and hopefully by the end of this we know a little bit of SQL. And so just to set up how this is all going to go, it's going to be super casual. I'm just going to run a little bit over the basics. There's no slides or anything like that. I'm just going to kind of cover basics from my trusty little notebook here about SQL. Where would you use it? Why is it important? And then I'm going to go through, we have a little bit of tutorials from some websites, which I'll link when we're going through them, just to cover some of the main commands and queries that you should expect when you're using SQL. And then if time permitted, we're going to go through some of the challenge, and, I'm going to try to work through them, and you guys are going to be here and we're going to work through it together. This workshop's not going to require you to download anything. We're going to cover the different types of SQL servers and things that you can use and the resources to program with SQL. But for this workshop, is not going to require any download. Everything's going to be online through the internet. So hopefully that makes it as accessible as possible. And yeah, so let us get started. Yeah, super pumped to be here. A little nervous, I'll be honest. I'll be really transparent. Yeah, first time. I kind of ran through everything the first 5 minutes before I jumped on, and I'm like, all right, hopefully this works out. But we're here, so let's do it. All right. So first things first is I am going to, let's see. So when it comes to writing in SQL, there are a few places where you can do it. So I want to show those resources first. I think the main one that I'm going to be using, because as I mentioned, I don't want to be programming anything with anything you have to download, is that I'm going to be, yeah, what can go wrong? Yeah, don't remind me. So this, if you are always thinking, okay, I want to get started with SQL, I don't know where to go or what to type in, or what resource I can use, I highly recommend this source. And so I just printed out it should be mycompiler.io. So this is an online free resource for you to be typing, coding in SQL, as you see on the top left. I'm going to actually share my screen just so you guys can take a look at that. Give me just a second. Share my window. You're going to see a double version of me in a second. Here we are. And there we go. So this is what I just linked, mycompiler.io. And so this is an online resource that's available for you, basically like an online IDE for you to type in. This is just what came in when you entered in the language or framework that you'll be using. As you see, this website's very useful, not just for SQL. There's a lot of languages you can use on here, but for all intents and purposes, we're going to focus on SQL. So later on in this stream, if you want to follow along and want to kind of try things out, feel free to use this IDE to kind of work through it. So just kind of wanted to link that right away. We're not going to be using it right now because we have some basics to cover, but I just want to make sure everyone has that resource. So I'm going to stop sharing. And all right, first things first, let's cover some basics. If you see me looking down, that's my trusty little notebook right here that I'll be working through. So biggest question I'm sure everyone is asking is like how to pronounce it. So you heard me saying SQL, but there seems to be a little bit of like debate on how it should be said. And so technically SQL, SQL, it stands for Structured Query Language. And so because it's an acronym, you really should be saying it as, saying each individual letter, so SQL. But as you may have noticed from me, and maybe other people, I did a little bit of history. So kind of back in the older English days and those who had really strong database backgrounds, they just tend to call it SQL. Yes. And somebody put the they're putting the pronunciations down there. Perfect. Thank you so much for that. So yeah, those are two different ways you can say it. I personally, from my experience, I hear a lot more people say SQL just because it kind of rolls off the tongue a little bit easier than saying SQL. But if you say either, people are going to know what you're saying. So just want to cover that quick because I know that there's always some debate over that. And then, now let's cover what SQL is. So it is a language that allows you basically to communicate with databases. We're going to cover what databases are too, because we want to make sure we get the full scope. And so SQL is really used for relational database management systems, or RDMS. And so SQL is basically a way for you to, if you want to extract information from a database or retrieve information, or kind of like if you want to do some data analysis with it, SQL is a really good tool in order to call on queries to grab or organize or structure the database in however you want in order to use for later. So for example, how can you use this in real life and practice? So maybe say, for example, I am a data analyst and my job is to go in and I'm like, okay, here's the database with all the information that we have on whatever topic. It's just full of it. And my job is to see, okay, I need to look for a very specific thing in this database, maybe learning how, the prices for one particular product. But this database has like hundreds of thousands of entries, and it's going to take forever for someone to just sit down with the database, scroll through it all, and be like, okay, where is it? So that's where SQL can be really useful, because you can use commands and queries to narrow down and restructure and organize your search in order to find it. And you can take it a step further by using other analysis languages such as Python and R in order to actually then, okay, you query, you get the information from the database, and now you can manipulate it in order to find anything that you're looking for. And so that's why when you're thinking of the term like data scientist or a data analyst or kind of anything in that realm, MIS, anyone, database managers, they tend to have kind of the trifecta of analysis. So that's Python, R, and SQL. If that's the path you want to go down, knowing those languages or at least being comfortable with them is a great way to start. And so that's where SQL is mostly used. In my personal opinion, it certainly is not as complex as something like an object-oriented language or something that's more like, C or OCaml or something like that. It very is something that's a lot easier for people to pick up. A lot of people who are just starting to get their feet wet with coding, they find that going into SQL and kind of databases tend to be an easier route, just because other than a few commands, it's generally pretty straightforward. So what are SQL servers? Yes, great question. Actually, we're going to cover all that. So I talked about what SQL is and kind of like that. Now we're going to talk about all the jargon that comes with it. And because there's a lot of pieces here, and me personally, I kind of did a little research myself just to make sure I didn't get confused. So we talked about what SQL is. So SQL, SQL, that is the language itself. And so, okay, so you have the language, but where do you actually use it? So that's where we kind of go into the servers and databases that are available. And the first one that I want to cover is kind of the difference between like SQL and SQLite and MySQL. You may have heard all of these terms going around. Like some people ask, what's the difference between MySQL and SQL, and what SQLite is. And so all of those words tend to get thrown around, and I kind of want to clear it up. Yes, thank you for posting that resource there. That's actually really good if you kind of want to go look more in detail about the name debate. Yeah, that's a really good resource to look at. So thank you for posting that. So first things first is talking about, okay, so the difference between MySQL and SQLite. So both of them are basically places for you to run SQL queries. And then one quick thing before I go is that I have, if you ever hear like a meowing or a scratching or a bell, we have my 11-year-old overweight cat. His name is Sage. He is very loud, he is very needy, and is getting close to his dinner time. So if you start hearing meows or just like the jingle of his bell, that's just him. Don't worry about it. Okay. So the main difference between SQLite and NoSQL in relation to SQL is that SQLite is more of a software library, and it's more file-based in comparison to MySQL, which is more, you need a server for it. So some people use SQLite, and it doesn't have a lot of it's not very heavy, and it's not very efficient in the sense that you're not storing a lot of information because it's serverless. And so it's definitely a more file-based system. So usually people who don't want to have to download everything, they just want to use something easier, they tend to go with SQLite, versus MySQL, which is owned by Oracle, that's going to be used for a lot more heavy-based work. And it's like a database server that you can actually run on a network. And so SQL, one thing to clarify, SQL is the language that you use. Things like SQLite and MySQL or Microsoft, you may have heard like MS or like Microsoft SQL. Those are all different softwares that you can use to run SQL on, and which one you use is depending on the project that you're working on. So if I'm working on something that's really, really small, maybe not a ton of entries, and maybe I don't want to take the time to have to set up a full-on server, I might want to consider something like SQLite. The light in the name is saying that there's not a lot of functionality there, particularly when it comes to types that you can use, which that's a whole other conversation when it comes to we'll cover that kind of in the intro. So maybe something smaller, you'd want to use SQLite versus something that's a bit more heavy duty. You have, hundreds, thousands of entries. You might want to look at something like MySQL or Microsoft SQL. Those require you to download a software in order to use it, versus the one that I had linked to you. So my compiler, that's going to be more of an example of like a SQLite-esque type of thing. And we'll see an example of that as well. So that's covering that. But then there's a whole other thing. So then there's NoSQL. So there are NoSQL database systems as well. And so we already know the SQL-based ones are relational-based. And so think about, for example, you have a table that has maybe a list of hobbies, and then maybe you have another table that has like the list of users. And so when you're using SQL, you're going to be running commands to try to join them together. It's very much so the relationship between different entries in the table and how they connect to each other. That's how SQL kind of interacts, versus a NoSQL database. And there's a lot of different names for that too. That's going to be more, that's going to be like more tabular. Well, it's a non-tabular based, and it's more covering like documentation and key value pairs and maybe graphs. So if you've seen databases that work with JSON, for example, that's going to be a NoSQL based database, because it's not going to be relational. It's going to be based on, okay, I have this entry that has JSON in it, for example. I need to store, the user, and then I can basically, if I want to retrieve the information, I'm pulling that entire JSON extract rather than just the relation between them. I know that's very convoluted and that may not make a lot of sense, but I just kind of want to cover all of the different bases. And so you might have heard things like MongoDB, for example, or Redis. Those are examples of non-SQL databases. So basically you don't need to know SQL for those, and those have their own separate uses. And for most part, the main difference is that non-SQL based ones tend to be a little bit more cost efficient, a little bit more easier to manage, because you're not using the SQL language. It's a lot easier to scale at that point because you're not dealing with like the relations between them. And so that's it's going to kind of cover all of that basically. So let me get that. Is the SQL syntax different between SQLite and MySQL. And I'll get back to that. I saw that JSON type. Yes, so it's very, very, yeah, there definitely is a difference between them. I'd like to say that if you know the general base of, if you know the general syntax of SQL itself, you can easily go between SQLite and MySQL. There is a difference between them. And so it's kind of like relearning some of the syntax, but the core of the language is the same. And so that's one thing to know. And so, sorry, yeah, I said, you mentioned JSON type and then I explained it. So yeah, so NoSQL also means non-relational. Yes, that is correct, because non-SQL databases tend to have like their own separate use case that I discussed. So that's a lot of talking. I didn't want to have to create slides for that. A lot of that information, just want to make sure that I covered some of the misconceptions that when it comes to SQL, when can it be used? Is MongoDB SQL? It's not. Just kind of wanted to cover all of that there. So yes, if any other questions that are coming in regarding this, please be sure to put it in the chat. I definitely would love to address it as best as I can. And if there's something I don't know, then we can look it up together and we can learn. But for now, so that covers the basics. Now we're going to actually start looking at some of the queries that you can do and some of the main ones. So I'm going to share my screen. So I'm going to be going off of this website. I'm sure a lot of you may have heard of if you're into the coding world. So basically it's w3schools.com. I'm going to post that here. So that's what I am going to be using. I'm not going to be going through the entire website. I just kind of want to highlight some of the main queries that you might be using. Just kind of setting that up, kind of going over some examples. I think it's a really good website that has a really good interface for beginners. And then once we do that, then we're going to start tackling some challenges together. And I'll share my screen as we work through that. So how does Docker compare to MySQL? Do they do completely different things? And then I saw the other comment, W3 Schools always got our backs. Yeah, pretty much. I was literally preparing how to do it. And I was like, okay, this is the perfect resource. That's a good question about Docker in comparison to MySQL. I'll be really honest. So Docker is a completely different thing. I've used Docker before. I am not very skilled with it. I'll be very transparent. And so I don't know if I can fully elaborate on the differences between them. They are different. They're for different uses. But just for the sake of scope, and also because I don't fully know myself, maybe at the end of the stream, if we have a little bit of time, we can certainly maybe compare things like Docker and like look into that a bit more. So I'm going to write that down if we have time. But yeah, so the simpler answer is that they're not the same. They do different things. Use hand in hand. Thank you for example. Yes. So yeah, if at the end of the stream, if we have time, we can certainly look through and see how they can be used. And there he's screaming. All right. So I'm going to share my screen. Give me just a sec here. We're going to go to you. And if you want to follow along or if you want to work ahead, if we have other things, you can just go to that link I provided. That's basically where we're going to be using. So, okay. So I think this is probably one of the better sites because it breaks down pretty much all of the queries that you have. And so just to backtrack. So a query essentially is saying, okay, I want to find something in a database. How I want to find like a certain row or a certain column or something like that. You can enter in a query in SQL, and then it will pull that information from the database. So that's what I mean by query or command. You're basically commanding to get a certain amount of info, and what you're going to receive is going to be based on what command you use. We're not going to cover through all of these. I just wanted to cover some of the main ones that are used and the ones that are going to be influential when we start doing our projects. So give me a sec here just to adjust my screen. All right. Yes. So, okay. So a stranded language for storing, manipulation, and retrieving databases. And then, yeah, here are all some of the other. So I mentioned MySQL. We mentioned Oracle. Postgres is also a different type of a SQL-based database. So, there's a lot of different things you can use here. And then now we're going to start going into the details of like how it works. So I starred the ones that I want us to cover so we don't go through everything. So basically this page is just going to cover some of the things that we have that I mentioned: structured query language, what can you do, using it for your website and how you can use it to get the data that you want. We mentioned, for server side, things like that. So just wanted to cover that quick. And then I guess we can look at the syntax a little bit as well. I forget if that's something we want to do. Database tables. Oh, right. Yes, I didn't get to cover. So this is actually a good segue. I forgot to mention something. Yes, I forgot to mention something, and this is actually a good way to mention it. So kind of going into the topic of database and kind of what exactly does that mean? I mean, we all kind of know we all kind of know what a database is, but I just kind of wanted to go through some of the terminology in relation to SQL so that we're all on the same page. So yeah, a database often contains one or more tables. So think about it. It's basically a table of rows and columns. So a lot of you guys are very familiar with this. You have all of your entries, your column names, and then your row entries for each of them. One term that I want to throw out is something called a schema. And so a schema is a structure or an organization or a outline of the database, and it can include a myriad of things. It can be what you're looking at right now. It can be the objects that are involved, the types of tables, the index. So when you're looking at this table here, when you're looking at the schema of it, I'm looking and seeing, okay, so it seems to have seven different columns that are available: customer ID, customer name, contact name, address. And so when somebody is saying, okay, I want to pull off something from the database based on the schema, that's what they're referring to. It's a very broad term just to kind of outline the layout of how the database is. And you might hear that term thrown around. Another term that I want to highlight is the primary key, which is something that for SQL databases and for our examples, we're going to be using a lot. And so a primary key is essentially, that's going to be the unique identifier. So that's going to be, if you're looking for a very specific entry within a database or a table, that is what you're going to be used. And as I mentioned, they're unique. And so no two entries are going to have the same case. And so when you're looking at this table, for example, my guess is that the primary identifier is going to be this customer ID. And the reason for that is because then you can just basically number it off based on, every entry that comes in, it's going to generate a completely new number. And we have primary keys because what happens if we have two customer names that are the same thing, for example? So say this average, gosh, I don't know if I can read that. Alfred's F, I'm just going to say that there are two of these entries in the same table here. How do we know that we want entry number 1 versus entry number 2, given that maybe all the rest of the information is the same? That's where the primary key comes in that allows you to basically grab that information. So now I know, okay, I want to get customer ID number 2, and it gives me this specific information. So primary keys are very important because that's really going to help kind of define your search. You define what that primary key is when you're setting up your schema. So just wanted to cover that there. And I'm going to be going back and forth checking the questions, make sure there's none here. Okay, so then SQL statements. Okay, cool. So now that we covered databases a little bit and we kind of understand what that is and schema, and we talked about what SQL is and the differences, let's now look at a few queries and see what we can do. So the first and most common query you're going to be getting in SQL is called the select statement. So basically, it's being used to select data from the database, as it says. So if you want to grab a particular column, grab the information from there, and you're able to actually then print it out onto the screen that you have. So let's look at the syntax here. So say, for example, looking at down here, I want to gather the information from this column. I want to get all the customer names and maybe the contact names from this database. So select, which notice the syntax here that they are a capital letter. That's to highlight. So that's for SQL to identify this is an actual command because it's highlighted in blue and we know that it's capital letter. So I want to retrieve information from column 1 and column 2, and I want to gather it from the name of the table. So this is important because you want to grab these columns, but maybe you have multiple tables, for example. Maybe you want to grab it from a very specific one. So that's why you have to clarify the table name down below. One quick way to do this, if you just want to kind of show the whole table, you have this wild card, which is this asterisk up here that basically allows you to just grab everything from the table. So if you want to specify certain things you want to grab, you have to list out the name exactly. Make sure that this is definitely, when it comes to spelling and spacing and everything else, you need to be able to have that correct. because otherwise it's not going to grab it. SQL's not going to know if you do customer name with with a 1 or a 2 behind it here. It's going to be looking for that at this table, and if it's not there, it's going to return nothing. So case sensitive, how everything is spelled in SQL is very, very important. All right, and so then now we can look at this example here, down here. So say, for example, they want to get the customer name and the city from the customers table. So this table is named customers, as we see here. We can get that from this call here. And they want to grab the customer name and the city. Take note that they add this 1 comma in between. So if you want to grab a single one, just put the name. If you want to add multiples, you have to have a comma between them. And so I'm just going to switch over here and I can run it. And now, as you see, it's going to, for every entry in the database that we had before, it's going to pull the customer name and the city it was associated with. Now, no, it's going to grab the customer name and the city from the same row. So basically, if you just want to grab, it's basically grabbing for each row these specific pieces of information from the columns that we specified. So that's what's happening here. That's a very common thing to do. It's usually very much used to limit the scope of what you're working for. So what you're trying to analyze, I suppose. So select is the main one. Make sure you understand that one. That one's very important. All right. So and you saw the example there. And then let's see example here where if you select from the wildcard from customers, if you try it yourself, you run it, as you see, it will basically just pull everything. So this is really useful maybe if you have a smaller table and you just, or maybe you're just working with the database for the first time ever and you need to see what's available and what's in it. So using this syntax allows you to print out the entire thing, and it prints out all of the entries here, as you can see. Alrighty, and so I am going to do a few more. It can certainly get very complicated. I mentioned at the beginning that SQL can be a little easier to learn at first, but if you're trying, so I know people who can do incredibly complex queries when they're looking for something specific, and that's just because they're really good at it and they kind of know what to look for, so they don't have to try to write a lot of redundant code. And so that's what I would say about SQL is that entry level, it's pretty easy to learn in comparison to other languages. But some of the really good people, they know how to they combine 5 or 6 of these in a single line, and because they're incredible at it. I don't know if I'm at that level of incredible, but that's where some people are at. All right, so say, for example, you want to pull information. So you've already been select. We've talked about that. You want to grab certain pieces of information from a row given the columns that you're clarifying, but maybe you want to list a condition. So maybe you only want to grab these information from these row if the total amount of money that they're making is less than $10 or more than $10. So this is very similar to when you're listing off those conditionals in regular code, like in Python or Java. But instead it's kind of happening at the bottom. So grab the information from these specific columns from the table that we're working with where this condition is being met. So yes, not only using select, I think we might cover delete. We may not cover update there. So here we go with the clause. All right, so this is an example of this. So select everything from this table where the country is Mexico. So that's basically saying, okay, I only care about the customers who are Mexico-based. Maybe that's the only one I want. So now it's only going to, and see how it pulls entries 2, 3, 13, 58, and 80, because it's pulling out the information only based on if the country here. So that this is going to be the identifier of what's going to basically filter out the information you're trying to get. So that's how where works. And also one thing I forgot to comment on before is that for SQL, you may notice a semicolon at the end. That's very important. That's also a syntactical thing. Just when you're running a query, you must be sure to have the semicolon at the end so that they know that that's one complete query. So you can have multiple queries occurring. I can enter in, select, another ... another query, but it's important to have this semicolon here to kind of differentiate between them. And I'm going to be going back and forth just to make sure that I get the comments. And hello. I see some people coming in. Hello. So, all right. So we'll do a summary. Don't worry. We're going through a lot of information quickly, just so people are familiar. But when we actually do the projects, I think that's going to be a lot more helpful so you can see how everything plays in practice. I know that I'm somebody like that who definitely I'm the professor is telling me something about how something works, and I'm looking and I'm like, oh yeah, that makes sense. And then they're like, okay, you got it. Now go and do it on your own. I'm looking at it and I'm like, I don't know what to do. I'm definitely that type of person. And so fully aware that we might be speed running through this a little quickly, but I feel as though a lot of the learning and the application of what we're really doing is going to be in the challenges. So just want to make sure everyone's familiar with that. But like I said, any specific questions, we can certainly stop. We didn't cover fields and like types that much, but I wanted to, that was one thing I mentioned at the beginning. There's something like SQLite. One of the main differences is, once again, just like the power that it has. It just doesn't contain as many types as MySQL, other types of database types. I can look up online the very specific types that SQLite requires, but just wanted to cover that. Yeah, you do. When we'll cover this. I'm jumping ahead of myself. I don't want to. I'm getting too ahead of myself. So text fields versus numerical fields, good question. So very similar for use to coding. So for strings or words or text values, maybe I should say, you want to have single quotations. As I mentioned, most will require also a low double. Safety wise, I would just do single. But numerical numbers, you just want to have the number. And the nice thing about SQL, for the most part, depending on the IDE that you're working with, it tends to color code when when it's formatted a certain way. So hopefully this kind of helps you see, like, okay, it's, this light red, so that's a number. And just to run this, if people want to guess to see what this is going to be. So basically, from the customers table, we want to select or grab pretty much everything in it where the customer ID equals to 1. So I'll give people just a quick second to think, okay, how many, based on a conversation about, primary keys and which one and how this is going to be identified, how many results should I expect to see when I run this query? I'm not seeing the chat right now, but I'm assuming everyone's pouring in, putting in tons of answers. Everyone's rushing in to get the right answer. I'm expecting people are doing that right now. So I'm going to run this. And if you said 1, you are correct. And the reason because this is a primary ID, there's only ever going to be one entry that has the customer ID of 1. And so if you're looking for a very specific row, using that primary key to narrow it down is going to be very helpful. So that's that. Hopefully you got that right. And then operations in the where clause. So we're not going to go into too much detail on all of these, but these are basically things that you can use in the where clause. As you saw here, it uses a single equal sign. So you may notice, like in coding, sometimes they'll use a double equal sign. Just make sure you note that syntactical difference, greater than, less than. Not equal. So in some languages, you may see, the exclamation point equals for not equals. In this case, it's going to be this double sign. Between, like, and in. These are actually interesting ones. So yeah, so that's where we're going to now cover and or not. So that's so now we're kind of building off of each other. So now we have a good idea of select. We know that we're going to grab it from a certain table. We're already listing the conditions, but maybe there are multiple conditions. Maybe I want it to be, maybe I want the value that I grab from the table to have a primary identifier less than 10, and I want it to be from Mexico. So that's kind of where the and or not comes in. So it can really filter your search. Or is true if any of them. Yeah. So one thing to note, like if you, like, once again, if you've been coding, this makes sense, but I want to clarify just in case, is that for the difference between the and in the or operator is that if you use the and operator, basically it's saying condition 1 and condition 2 and condition 3 must be individually, I'm going to say correct, but it needs to meet that criteria. So it can't, if say, for example, conditions 1 and conditions 2 are met, but conditions 3 is not met, this would not print out anything that it's looking for. In contrast to the or syntax, where it's basically saying as long as one of these conditions are met, then it'll print off anything that relates to them. So that the and syntax is going to be a lot more narrowing down in scope and filtering out, because it makes it a lot smaller. You have to, what was I going to say? you have to meet a lot more criteria than or, where basically you have to meet at least one of the criteria, if that makes sense. And then same for not, well, not same for not, but not basically saying make sure that it's basically the opposite. So I do not want to grab condition customer ID number 1 is going to print off customer IDs 2 through however long it takes. So we'll look through an example here. So I'm not going to run the try it yourself because, we're just going to see that same table. I just want to highlight the syntax where they want to grab from the table customers where the country is Germany and the city is Berlin. So it's not just enough for it to be in the country Germany. It has to be specifically in the city. So that's one way to write this out, or the or statement. So maybe you don't care where it is in Germany. As long as it's somewhere within these 2 cities, it doesn't matter. So that's another way to word it. And then example of a not is I don't want the country Germany. I want everything but Germany. So that's the and, or not one. And any questions? I'm going to look through one. Yes. Oh, yeah. I'm looking back on the chat now. Now I'm seeing all of the flow. Yeah, there it is. The flow of people putting in the answers that they have. Yes, everyone's super fast, super smart. And then Sql is good to know, especially if you go into a data-intensive job. Yes. What is the default priority for and, or not? That is a great question, actually. That is a really good question. And so that's something we could actually try to experiment a little bit here. My understanding of it is that it's not. So this is actually a good, I think it actually covers it here, where I think the parentheses takes priority over the 2 for complex expressions. And so I don't think, let me backtrack. I don't think there is an inherent like and versus or versus not, like one of them has more than the other. I think it might just be left to right. I'm gonna look back at the chat if anyone has specific things. If somebody has like the specific answers for that, actually that's a really good question. Let's experiment. Priority for and or not in SQL. You guys are asking smart questions. I don't know the answer to that one. So let us experiment on it. All right. So one thing to note is just Stack Overflow. If W3 Schools has one of my backs, then the Stack Overflow has the other one. So here we go. So are the 2 statements below equivalent? We have select. So these are some that we know. We know what select does, and we know that what from does, and we also know what where does. And so we're some column and in or in. Is there some sort of truth table I can use to verify? Here we go. So I think this is the answer that you were looking for. So and has precedence over or. So even if A and A1 or 2, so okay. So yeah, it's not the same as. So basically the and takes precedence over the or. So if it's saying, so A1 is not saying the same as what A1 or A2 and B, because that would be executed as A1 or A2. And yeah, right, executed. It's not the same. Got it. Okay. So and takes precedence. So it's essentially, if you have the and, it's going to be looking at these 2, making sure those are. So basically, in order for this statement to be true, we're going back to discrete structures, y'all. If you took computer science class, discrete structures, this is what we're doing. So basically, it's saying A2 and B need to both, that needs to come out a true statement. Versus, okay, here I'm trying to like sketch it out in a way that makes sense. So basically, let's say that A2 is the country Germany, and B is like the city. So maybe we want it to be in Berlin, for example. So basically, this example is saying that we want it to be in, if we're looking for a specific value to pull out from the query, it's saying that A2, so it has to be in Germany, and it has to be in Berlin. If for this to be true, if both of them have to be correct. And then it's saying or A1 or this one. So think of this as one pure one. So maybe A1, for example, maybe it's saying that, I don't know, like the customer ID is less than 10. Is less than 10, for example. So basically it's saying as long as, whereas A1 is the customer ID is less than 10, or they're both, the entry is in Germany and in Berlin, then print off one of the two. So if this statement wasn't true, it wouldn't do this statement then. I believe that's what it's saying. I'm going to copy paste this because there's a lot of information here and somebody might be explaining it a little better than I do. So I am going to post that in there if you want to look more. That's a really good question. I'm glad you asked it. Astronomy is now exchanged using the type. So the answer is yes, there is a priority to it. I don't know the exact priority of versus like or versus and versus not, but I guess we'll learn that as we practice. And so if you want to very much specify, use more parentheses than not. Oh, basically what this comment is saying. Basically use more parentheses than not to kind of like isolate where you want your ands and your ors and your nots to be. And then basically no parentheses mean it's probably just going to read it from like a left to right unless there's an inherent priority there. So great question. Great question. Hopefully that makes sense. Here we go. And just one more quick thing to say here is so select from country. We're not country. So basically it's saying we don't want the country to be Germany and the country should not be the USA. So in order for this to print out, the entries have to not be from Germany and not from the USA, if that makes sense. All right, we're going to go through a few. I think we only need, I'm looking at my timer here. We only need a few more of these before we can start doing examples, because that's the fun part. I know this is not the fun part that much at all, just kind of going through all this info, but I just want to make sure we're all caught up to speed. We're going to do order by. That is the next one on the list. So all of the ones up to this point that we've been doing, the selecting and the where and kind of the conditionals, those have been working a lot with filtering out and gathering the information and showing it and retrieving it onto the IDE. The order by is going to be less of, restricting or enabling certain values to be presented, as more so as organizing them. So SQL is not just a way for you to just pull in information. It can also be used to restructure and organize it as well. And that's what this order by key is going to be using. So basically it allows you to set it in ascending or descending order, and you can specify that down here. So we're already aware of selecting the columns and from the table name, but maybe you want to order it by something. So I want to order these columns. I want to restructure the schema. There we go, using that keyword. Order it by these columns. And maybe I want to do it in ascending to descending order. And I believe the ascending and the descending order is by the traditional like alphanumeric setup. So if you guys are aware, like, A to Z, and then I think like the numbers kind of fall. I forget where the numbers fall in there, but if you're wondering, okay, how does it know for a something that's not a number, how do they order it? I believe it's just like the alphanumeric way to do it. So let's look at it here. So this is a good example. So they just want to grab pretty much that table and they want to order it by country. And so, yep, just as I suspected here, it will order it based on the alphanumeric version. So it's an alphabetical order, essentially, for non-numeric. So numerically, it would do, the lowest number to the highest number. And then non-numerically, it would just do it based on the letters here. I think I'd be curious to see if there's a mix of both letters and numbers, but I don't think you can do that because it has to be of a certain type, which is going to be the next thing we cover is types of these. So you might notice that some of these are numbers, and some of these are text, and some of them are a combination of numbers and text. And so we're going to cover that soon. I believe. Right. One more thing to know is that if you want it in a ascending, from lowest to highest, basically, you don't need to specify ascending. You do need to specify descending, which I think is going to cover next. If you want it to go like in the reverse order, here we go. So if you want to do it in reverse order, you do have to specify. If you just want it to be normal, you do not have to specify. So this is going to do the opposite. I have so many tabs open, and it's going to go from Z to A, essentially. I'm going to close all these tabs. I don't know if some people may be like me who have like a million tabs open. I always have like 20 to 30 tabs open at one time. I know it's not good. I know my computer runs slow, but I always have this thing where it's like, oh, maybe I'll need this tab later. And maybe I don't want to close the tab because then you have to remember to open it again. And then what if I need to do a task and I know the tab is open and it's like, oh yeah, I was filling out this form. So sorry, an aside, but I am very much a tab person. So I constantly go back and forth with keeping my tabs open there. And so, so now it can get a little bit more complex if you want to order it by multiple ones. So we already know that if you want to do multiples, you have to use the comma. And if we run it here, it's going to do it based on the country and the customer name. So my understanding is that it will, based on order, it will order it based on the country first. So it'll always do the country first, and then it will do the customer name within it. So since it's doing it by country name first, it's always going to pull the first ones, which is Argentina. And then within Argentina, it's then going to order it by the customer name. So it's kind of like in an embedded loop of, okay, first the country and then the customer name. So if you notice here, it does COR, and then it goes to the next one. Then we're in Austria. Then it organizes Austria's based on the customer name. So the order in this particular case matters. Order, and then you can specify if you want some to be ascending and some to be descending. You can clarify that as well. And so I just want to show that quickly. So then now it does it in the opposite order, so you can structure that there. All right. I have two more things before we start the exercises. The first one is insert into. So we not only can filter and not only can we organize, but we can also enter in values into a table as well. So SQL is very versatile. So it's not just you could just pull the information, but you can also like edit and adapt. And that's kind of where the data science, data analytics piece of it comes in. And that's what we're delving into now. So insert into is basically allowing you to add new records to the table. And there are two ways you can do it. So basically, if you want to insert into the table name, so I want to enter in the values for all of these columns. So basically column 1, column 2, and then after you specify the columns, then you have to enter in the values. These are in this particular case, it is a 1-to-1 order. So say, for example, let's see if I can find it here. So say if I want to enter in the values, I do insert into, and I want to insert into the customer name, contact name, and address. When I enter in my values, it has to be in that order, unless you specify it otherwise. But so if column 1 is customer name, then the first value that I enter then correlates to the first column that I enter. So just keep that in mind, Theo. You can't just put this in random order and then think that SQL is going to magically insert what you want into the correct column name. You do have to make sure that there's that correlation there. So that's one way to do it. That's the most straightforward way. And then if you're adding values for all of the columns of the table, you don't have to specify the column name in the SQL entry. And then making sure it's in the same order here. So this, basically you can either insert it, but if you're adding it to all the columns, you can just say, put it into the table, and then I'm going to put the customer ID, customer name, blah, blah, blah. Or you can say, I'm only going to be inserting based on these values. So let's look at this database, for example. So we have the customers, but it looks a little bit different. So we're probably going to see two examples of this. The first one is I want to add a new row to this table here. And I want to enter in these specific values. So the customer name, contact name, address, city, postal code, and country. And as I mentioned, the names are going to be going to correlate to the city. So I'm going to play that, and we're going to run here. You have made changes to the database row affected one. So that's interesting because it's like, okay, that didn't show me what you wanted to see. And so that's where now we have to go into the next part where, okay, this insert into, it doesn't actually print out the value that you want. So maybe now I'm like, okay, we've added it there. I would like to see that value has been added to the table. So now we're kind of pulling in some stuff that we learned before. So I want to look at all the entries in this table from, I believe it's just customers, right? And then I believe I have to do this. Make sure I did it right. Oh, cannot prepare statement 1 is not an error. So here we go. So now we are getting into some issues. I only select from customers. Or maybe it wouldn't let me do that. 1 cannot prepare statement 1, not an error. Interesting. I thought I could just like print it out, but maybe this is only for a specific thing. We're going to keep going. Maybe I can show that in a sec. Oh, okay. It just, I think it might have been this specific example. So here's what they were actually entering in. So here's the cardinal, And one thing to notice that you didn't have to enter in the customer ID here. And that's because that is going to automatically going to populate because it is the primary identifier. We will see an example of how to set that and kind of set all of these types in a minute. But note that they didn't have to do customer ID and then put the number 92 because that's already manually updating based on the entries being inputted in. So keep that in mind. I'm gonna hop back here. Any questions? No. All right. And then, yeah, if you want to add values to specific columns, this is also an interesting thing. So now maybe I only want to add these 3 values. Maybe I don't know the contact or the address, but I still want to enter in the customer name and the city and the country. You can do that. And as you see here, it's going to reveal a null entry. So essentially, they don't have any information. It's just going to be a data type of null. There's nothing there. And you can go in and add it if you want. But it still creates that whole row. So insert a new record into the table. All right, so the last thing I want to cover before we start actually doing some examples is, so this covers null values. We kind of talked about it. Updating, I'll cover this very briefly. So updating basically allows you to set, so you can update the value. So rather than putting in a new value in the table, you can update the values in the table, and you can do it by column and then set the value. And then you want to set a condition. So this is very important. The condition is usually going to be like the specific customer ID. So say you want to edit the value, you want to edit a very specific entry in this table. I want to edit customer ID number 1. So your condition has to be where the customer ID is number 1, and maybe I have a new name. So then now you can update it to the contact name here, and maybe they move to a new city. So that's how you do update. Delete's very similar. If you want to delete a very specific thing, you basically just specify it. That's not what I want to cover. Just want to cover that quick. Is finally, now this is kind of once again more of the analytics part. So the count, average, and sum functions. So it returns the number of rows. So count basically returns the number of rows that matches the condition, if there is a condition, or it averages it, or it returns the sum. So let's see an example here. So here is the products table in the Northwind sample database. And I want to basically count the number of product IDs. So basically, how many entries do we have in this table? So when we run that, let me do that here. And now we know that there are 77. So basically, it's saying that there are 77 different entries for the product ID. So now we know that there are 77 of them. So that's basically how that works. The averaging. So maybe you want to say, okay, based on all the entries that we have, what's the average price? How much are they spending? Very similar. And then there is, nulls are ignored. Nulls count as like a 0. I don't think it counts as a 0. I think it just counts as it doesn't exist at all. Like it won't even be an entry, I think. So it wouldn't like count towards. So say there are 77 entries and there's a null in there. I think it would just print out 76. Someone correct me if I'm wrong. I believe that's what it happens. I don't think it counts. Null does not equal 0 in this context, just to clarify. And then sum, it will basically sum the quantity. So maybe you want to add all of the different, how much does everyone order collectively, and you want to summarize, add it together. So in this case, you run it, and so you know the total sum is here. So that's a little bit more data analytics pieces. All right, so those are essentially all of the main ones. As I mentioned, there are so many of these in here, especially when you start getting into more complex, like you want to join tables together. And so you have to join it by the primary key. You want to do a left join, a right join. You want to unionize it. You want to select into. There's some case setups and some null. There's so many of these here, and we could honestly spend an entire session just going over all of these details. But I want to now transition, now that we've gotten into an hour, into actually doing some examples and some practice problems to see how this all plays together. Before I do that, though, I know that was a lot of me talking for an hour. And so we're just going to take a quick breather. I'm going to stop sharing my screen for a sec, just a quick 5-minute break just for people to relax. If you want to get a drink, I got my water. We can chill a little bit, and then we can transition into the practice problems. So does anyone have any questions, or people excited? Why this stream? Do people want to learn SQL for later? Are they seeing a career path in it? I just love to hear more about all things SQL, I suppose. People are interested. I know that I was thinking about doing like going into data analytics and like data science a while ago. I don't know if that's the path that I'm on now. I know that R is my weakness. Some people really are good at R. I am not good at it, so I feel like that kind of cuts me out pretty much of any data science or data researcher job there, which that's okay. But that's certainly something that I'm working on. So, all right, I'm just gonna get rid of all these tabs. So some people don't like those tabs. And so now here's the point where if you want to follow along, I will relink here we go. I'll relink the compiler because now we're going to start actually doing some examples. We're going to start with, let's see. We'll start with this one. We'll kick it right off at 5 o'clock. Well, in 3 minutes. It's useless for me to say 5 o'clock when we're all in different time zones. So we'll wait a few minutes and then we'll kick it off. And we'll probably do, based on time, we'll do one for sure. If we have time to do a second one that's a bit more advanced, we'll do it. And then we can kind of wrap up at the end if people have any other questions or clarifications. Yes. Yep. Exactly. Seems useful to learn is a good starting point for working with databases. Yeah, that was one thing that I wish I would have done more of. So at least at my school, when I was in college, I didn't take like an official databases course. I don't think it was it was an elective that you could choose to do, but it wasn't ingrained in the curriculum, which really sucked because I really would have liked to learn how to do that. And so now if you want to learn things like SQL, you kind of have to do it on the side. But good news, it's easy to learn, easy to get good at. I guess to get great at, there's a lot of practice there. So I wholeheartedly agree with that. All right. Second half. Let's go. I'm going to now share my screen, and now we're going to start looking at some examples. So let me do that. Share screen. We're going to go to this window. And we'll go to this Chrome tab. We'll be extra fancy. Spin-off, design, any store database. All right. So the example that I want to walk through is create your own store, design a store database. So maybe you are lucky enough to get an internship and they're like, we don't have a database. We've been collecting all of this information on paper. And now I need you to create this database so that, we can use it for later, that it's scalable and we know how to set everything up. So that's what this is going to be using. This example is based off of Khan Academy. Once again, it's the trifecta of Khan Academy, W3 Schools, and Stack Overflow. Those are the resources that we're using here. But I'll read this out loud. So create your own store. Your store should sell one type of things like clothing or bikes, whatever your store wants to specialize in. Have a table for all the items in your store and at least 5 columns for the kind of data you think you need to store. You need to sell at least 15, and then you select to order your items by price and to at least one statistic about the items. So when it comes to handling a problem like this, there's a lot of requirements here. You see at the end, they're just listing off, here are all the things that we are going to be expecting you to be doing. Let's kind of ignore that for a sec. The first thing we have to do is set up the database. We need to set up the schema and make sure, we have to have all the different types that we have, which I didn't cover in those examples because I feel like it would be easier for me to just show that off here. So in order to officially create a table or a database, what you need to do, the command is create, and it's going to be basically create table. So that's what I'm going to be using. I want to create a table, and then you can pick the name of the table that you would want. I'm going to, what store? Do people have stores that they want to list or ideas that they have? I'd love to hear them if you do. Clothing. I might just do clothing. That might be an easier one, right? I don't have to think about it unless somebody has any ideas. Any takers? I'm going to do clothing. Oh, there's a syntax. Yeah, this is really cool. So it actually lists off like where the syntax is, and it shows you where it takes you. Obviously, this is not finished yet, so there's nothing there. But I'm going to call this clothing store. maybe let's call it clothing. We'll call it just clothing. So this command is creating the table or the database, and then this is the name of the database that I want to have. And I believe, let me exercise, I forget, let me check. Comment in SQL. I forget, I think it's the same thing as like as JavaScript. I believe it's just the or Java, excuse me, maybe not. So if you want to put a comment in here, I always do the number key because I'm always functioning in Python. No matter what language I'm doing, I always default to like Python. And so if you want to leave a comment, it's going to be the dash asterisk, and then if you want to close it, I believe, or was it? How did they do it? They did. Oh, I see. It's star and then dash here. Yep, here we go. So this is how you write a comment. I'm just going to use this because I want to comment on the syntax of everything. So just to note, here is we have, oops, I spelled it wrong. I removed it. So create table, that creates the database. That creates the image that you're going to see on whether you do it in my compiler or not. That's going to create the actual like format that you want it to be in. So you have create table, and then the entry after that, afterwards, that's going to be the name of the database that you need to refer to later on. So just want to have that there. So now we have our create table. We know we want to call it clothing, but now we have to figure out, okay, what's the actual, like, the column names, what are they going to be? Because we need to list up the column names and we need that primary ID. So make sure you don't forget that. So, and we need at least 5 columns for the type of data that you want to store. So the first things first is thinking of, okay, I want that primary identifier, I want that numbered, or it doesn't have to be numbered, but that way to pull off the information. I think the easiest way to do that is just to list it off like before with the numbers. So product ID 1, 2, 3, and then go down for everyone that you make. And so for me to do that, I'm going to call that clothing ID. And from that, in order to specify the type, you just basically type it in capitalized. So if I want this to be an integer, I am going to enter an integer here. So this format is basically saying, here is the name of the column that I want it to be, and here is the type of the column that I wanted. So I'm going to also put that in comment so that people can see that. So afterwards, in parentheses, and you can enter in multiple values, as I mentioned. So you want to have the column name and then the column type. So once you list off the column type, that is once you have the type for the column that you want to use, you can't intermix like different types. So if I'm making this an integer, I can't just then start putting in text. So this is what's entering the schema at first. You need to clarify what it is to the beginning, and then later on, then you can make edits to it as you wish. But that's not enough. If I want this to be the primary key, this is a very specific thing. I need to enter in primary key. So then it knows. So now this is kind of like splitting it up. And then primary key, which is true or false here. So basically, if you don't enter this in, it's false. Otherwise, I want this to be the primary key, so it's true. So that you only need to do that once. You don't need to enter in primary key equals false for all that other stuff. You can just have that there. And then comma. So now that is going to list off one of them. But let's just debug. One thing I like about Khan Academy is that its UI is fantastic. The website that I linked to you, that one it still works pretty well, but it just doesn't make things look as like pretty. So just for me showing you, I'm going to show it off of here, but the ones you're working on is going to be a bit more like less refined is the kind way to put it. But let's look at what we have here right now. So we have the name of the table, which is clothing. And we have 0 rows because we haven't inserted anything. And we have our name of the column, which is the clothing ID. It says PK in parentheses, which indicates that it is a primary key. And then we also have the type. And so and then it mentions database schema. So that's one kind of data that we have. So maybe, okay, so maybe now then what's the next thing? Well, we probably want the name. We'll do clothing. That's too much. I'm not gonna do that. We're gonna do name, and I want that to be text. I'm gonna try to get as many versions as I can here. So now it updates it automatically. So now we have the clothing name here, and we have the text. Does that make sense? Oop, I am seeing a spammer. That's not good. I don't know how to. Oops, don't want to show that. That's not good. Give me just a second here. As I mentioned, I am new, so when it comes to, I see spammers on, and I'm like, how do you get rid of the spammers? Oh, I like that IKEA. I just saw the comment there. I'm gonna change it. Oh, it works as well as their difference. Okay, so first things first, I saw the IKEA. I'm going to change it to IKEA. I like that a lot better. I think that's fun. So we're going to call this IKEA. And we're going to do IKEA ID. So basically what I do, and we're going to call this the name of the product. We're going to, maybe we'll just call it product IKEA. Second thing is, it seems like you said this works as well. Testing. It does work the same. Good question. Let's learn and find out. So dashes versus asterisks / for comments in SQL. Okay. How do I stream? Okay. So I am going to, is there any difference between them? Oh, okay. So answer to I found, which I will link in the chat if you want to read it. It only really matters if you want your SQL to be portable. For instance, so the double dash are okay in SQLite and Postgres, while the pound, which actually can be used, is not available. So your best bet is to use double dash with the space following. So the two dashes is the standard comment separator, but it seems like there are different ways to do it. So like MySQL, for example, has like the more Java way to do it, and then there's some other ones that maybe have the more Python way to leave comments. So great question. I'll put this in the chat if you want to be reviewing all this information. Here you go. So that's what I used to look at the difference there. Great question. So then now that we know that, so now we need some more values inside of this. We need at least 3 more. So, okay. So we have a primary key. We have the name of the product that we want. Maybe we should have the price. So how much is it going to cost? Or maybe we'll do cost. That seems more efficient. We're going to do the cost. I want that to be an integer, right? Because another question is like, is it going to be integers versus, some people ask, is it going to be a float value or a decimal value? I believe that for SQLite, which I think this is in right now, it doesn't have a very full range of types. So if you want to have like the full range, you probably want to go with something that's a bit stronger, like MySQL. I'm going to pull up a link to kind of go through the types that are available, just so you can kind of look through that if you'd like. Data types. We're going to pull that information here. Here we go. So I am going to copy paste that. So that's what I am using here. So if you want to look at the different types that are available, as I mentioned for SQLite, there's not a lot. There's not a lot available. And obviously, depending on which one you use, depends on the types. But for our case, all we really need is an integer and a text. And then obviously the primary identifier if we need to specify that. You could also kind of do like real. I guess real is a floating point type. I see. So maybe if you don't want to do like an integer, that could be something you want. And then I probably want, so let's go back to here. So we have 3 out of the 5. What other things do we want to have here? I probably want to have like inventory, like stock, like how much of them are available. That's also going to be an integer. And then we probably want one more. Let's not have it be an integer. Let's have it be something different. Maybe we could have, so we have the ID, the name of the product, the cost, the stock. Maybe we want to have maybe where you can find, well, we have them in stock. Maybe you can just do like a description. I feel like that'll be a really long one though, like a description for it. Or we can do rating. Oh, I like that. Good. That's a good one. Yeah, I like that. So maybe rating, like how people would approve it, which would also be, so that one would probably be an integer if you're trying to do it out of 5, or if you wanted someone to leave comments, like saying, hey, what did you think about this one? That could also be a text. It really just depends on which one you want. In my case, just for simplicity, I'm going to make it a integer. So with that, that is how you set up the table. So note that I have the semicolon here for each entry that you put in. So each like query, so this is its own specific query. Creating the table, that's its own command. So that command is finished. I've created it, and now I put a semicolon. So make sure you don't make the mistake of leaving the semicolon out and then trying to do other things like this, because these are two separate commands, and it's going to, yeah, here we go. That's one thing also why I like Khan Academy, because it also clarifies that. So you put that there, and obviously there's a syntax error here. All right, so now that we have set up I got my charger, we've set up the table. Now we have to actually add the values to the table, which we have covered. The way to add values to the table is essentially that inserts into, and which was what we covered before. So if I want to add a single value, I'm going to type in insert into. And we remember there are two options. The first option was to specify the columns that we wanted to insert values into, or if you just want to enter into the entire table, you can just type in the store name. So in my case, I just want to add into IKEA the table right away. And from there, I then have to add, okay, so I'm entering into IKEA, and then now I want to enter in the values for it. So these are like two separate things. Some people separate it onto separate lines. If you want to, I am not going to in this case. Yes, being a, yes, I know, I am aware there are issues. So now I want to, let's see. In this case, I want the values to be, I want to test something, but first things first, we're just going to enter in the ID, the primary key, which I know I mentioned before that you shouldn't need to enter it in. I might have been wrong there, so that's why I'm going to test it right now to make sure that we get it right. So we have the ID, the next is going to be the product. Make sure you add your single quotation to specify that the product and not a number. I want it to be a chair. The cost of the chair, I am going to, in an ideal world, a chair would be like $7. That'd be great. If in this economy, I don't know about that, but it'd be great for a chair to be $7. The stock, so how much shares available? How about it's very low on stock, there's only one left, you better run in and grab that share now. And then the ratings, so I'm going to leave a comment here just for some other imaginary person to be looking at my code. So ratings will be from 1, with 1 being the lowest rating, to 5 is the highest rating. Yeah. So now then people know when they're looking at this code, like, oh, they're putting in some random rating number. What does that mean? I'm going to say this is a quality chair. That's why there's not a lot of chairs here. So now there's one row that's available, and you may be noticing that you're not actually seeing the information. That's because I haven't selected and shown it. So very similar to when you're thinking of like Python or whatever. I made this mistake all the time when you're entering in, you're trying to type in a function, and then you run the function and then nothing happens, and you're sitting there and you're like, why is nothing printing out on my terminal? It's because you need to actually show it to the terminal. So that's where the select is going to be occurring, which I would see how I made a mistake there. I need that semicolon, and there we go. That's why it wasn't showing. So the select here, select from IKEA. So now you can actually see the query results, which is actually a good clarification. Let me cover it now. So the difference between the database schema, so that's all happening up here, is here's what this database is going to look like. And here is the actual query that I'm running that I want to see the data that I'm pulling from. And then this one's kind of more of a manipulation. So consider this to be, I'm going to make some comments here. This is the setup of the schema. And this is the manipulation or edits of the table. And this is going to be showing the results, which are filtering. I like to think of those as kind of the main formats of SQL. You're either setting up the table, you're either making some edits or changes to the table, or you're filtering and showing the table. And there are a lot of different commands that kind of fall onto all of these, but that's just how I'm going to separate it like this, just so that it kind of makes sense moving forward. So now you see I have my IKEA ID. You have my product, I have my cost, I have my stock, and I have my rating. I'm very curious if I don't. So let's see what happens if I don't follow this. I'm going to say I try to get rid of this schema here. So here's what happens. It says table IKEA has 5 columns, but 4 columns were supplied. So it's saying I'm expecting 1 more column to be here, but you're not putting any information. So I might have been wrong before. Maybe it was the way that particular website it set up the schema where it just auto-populates. But in my case, I do have to put the ID in here. All right, so then it says I need 15 of these. That's a little bit of overkill. I don't know if I want to do 15. So I'm just going to do 5. And while I'm doing that, basically you can just kind of copy paste. It's kind of mundane. Of course, there are ways you can do like loops or whatever to try to add more values. That's covered on that W3 Sql sites that we were on. For this particular example, I'm just going to do it manually just so we can visually see all the options. Are you specifying a different value for each row? Yes, this is also a good point here. So the unique constraint failed on column, and then it tells you the column. Are you specifying a different value for each row? So when this tries to compile, it fails because, as I mentioned before, the unique identifier needs to be unique, because otherwise it wouldn't. How would you know that you're entering in this chair is different from this chair? So I need to change all of these values, and notice how all these other values can be the same. I can have the same product, I can have the same cost, stock, and ratings, but the actual unique identifier is what's going to help me find what I'm looking for. So keep that in mind. So we had a chair. I'm going to do a bed because I was just shopping for a bed recently. Because I was at school all the time and they always supplied us beds and mattresses, and now I am an adult and I need to actually get my own mattress. And spoiler alert, mattresses are very expensive. Say I want to buy a table, and I want to buy a decor, and then maybe I want to buy what else? I haven't been to IKEA in a hot minute, actually. It's been a while since I've been to IKEA. And I want to buy, what do I also want to buy? I want to buy an ottoman. Not just because I was looking at my ottoman and I saw it and I was like, oh my gosh. Category, rating, size, legal style. Yeah, I know. I saw all the different things that people are saying. There's a lot of things that I could have done style. Size would have worked out too. That would have been good. There are a lot of options I could have had here, and you could keep adding them on if you want. So now that I've run that, and this will then updates automatically. So now I'm just going to throw in some automatic numbers. The beds are expensive. I want to be like $1,000 because it's expensive. A table, I don't know, like $25. Decor, we're going to make it 10. And the ottoman wasn't too bad. I think it was like $40 or something like that. Stock, there's only one of these. There's 10. It doesn't really matter what number I put in here. Quick thing, can I put a negative number in? You can. So obviously, in the case of in the context of this schema, it doesn't really make sense for me to add a negative number here. But you can technically put a negative number here. So that actually kind of ties into the whole idea of data engineering and data cleaning, which is like miles and leaps ahead beyond the expertise that I have. I can't really go into too much detail there, but a lot of the times before you can do all the glamorous work, you kind of have to go in and clean the data. So maybe that's what an engineer will do. They'll look at the database and be like, oh, that's a negative number. That doesn't make sense. And because if you try to run some analytics on the stock, and say, for example, you try to sum together all of these stock information, and now you're getting a value that's 3 less than you anticipated, but that's because this is -3 and there is no stock of -3. There's a stock of 0 if you want to. So that's kind of the job of the data engineer, to kind of go in and make sure that all that information is clean, it makes sense, so then they can pass it on to the data scientists and the data analytics to actually do their magic. Or all of those tasks could be embedded into one role, depends on the company and what they're asking for. Decor. There's a lot of decor. I'm gonna say there's 56 of the decor and ottomans. There is 3 of them, and then I'm just gonna do a rating. Amazing bed. Amazing chair. Not so great a bed. I don't like the bed. And let's try another thing. So say maybe I wanted to do a decimal. Let's see if it's possible. Yep, you can do decimal. So it says integer. And I know that in certain coding languages, you might think of integer like, oh, it has to be like a full whole value, and sometimes it can need to be positive depending on how you specify it. In this particular case of SQL, when it says integer, it's just saying a number. So yeah, you could have a decimal if you want it to. So maybe I'll do, just for clarity, I'll do like a 5.0, 2.5. Great table. Okay, decor. I'll do like 3 out of 0. And then this one we'll just do, I'm going to do a 4.4. All right, so now we have set up our table schema and we have put in all the values that we want to have in there. So we have a table for all the items. It says 15. I'm not doing 15. And then you select statements to order your items by price and show at least one statistic about the item. All right, so I need to show it by price and show one statistic about the item. So in order to order it by price, I need to use the order by command, which I'm going to do over here. So this is, once again, shows you what I want to see, all the values in this table, and I want to order by. And how do I want to order it by? I can order it by rating. I'm going to order it by rating, and you can either rate it. I want the highest rating ones first, which I don't have to specify that it's higher ratings because I think it does that automatically. Oops, no, I don't want to spin off. Order by rating. We'll just organize that for myself for me. Or do I need to specify the ascending? I might need to specify the ascending. Select from IKEA. Oh. Did I spell that correctly? Order by rating. Give me just a second here. And that. I wonder what's not ordering by rating. Give me just a second here. There's a queue. Okay, I'm gonna do the second part. I'm just gonna have all the information. I don't know why it's being a little weird right now, but okay. So then the next part here, so you can specify. I can have two separate things if I wanted to, of the different selects. So I'll order and show at least one statistic about the items. Maybe I want to have like the average, or maybe I want to do the average rating. I think I actually kind of want to do that more. So I'm gonna do an average of the rating. I want to see what's the average rating of all our items, see, like, how well are we doing at this business? Maybe that's something somebody hires you for. It's like, here's all this data, but how do we make this data make sense? That's the beauty of Sql and what you can work there. From IKEA, so select from, I want to do it from IKEA. And then order it by price. Okay, so maybe I might have messed up that there. From IKEA, so now you can see the average rating is, I'm gonna get rid of this. I might get rid of this bottom part, or I might just give in comments for now. Oh, interesting. Okay, so it showed it, but it didn't like the ratings. Hold on. So I still want to see that, and so now I can select my average rating from IKEA, and I do want to order. I wonder if I can combine it all. I think I can. I'm gonna order it by rating, if I can do that. Why is it not ordering it by rating? I might have messed something up. Cancel that out. Select average rating. So I need to keep that there. From here. All right, so now we do some small debugging just to make sure that I set this up correctly. So select from here. I want to order it by price rating. I have it as an integer, right? I'm going to go back here. There's a queue. Wonder why it's not doing that. Here. I wonder if I'm going to try something else here. Quick. To move my pants down. When you want the code to work, but you don't know why it's not working. Working 9 to 5. Wonder. Let me try a different one. Maybe I'll try by. Should I try by product? Okay, so it is sorted. Or maybe it was already sorted. Maybe I'm just stupid. Maybe it was already sorted. I literally was like looking at it for a while, and I was just like, "Why is this not sorting?" And then I realized it was literally already sorted by the way I wanted it to be sorted. Okay, cool. Oh, I just heard my cat. Oh, he just made the weirdest sound. Here you go. Hey, sweetie. Yeah, I know. Yeah, he's hungry. We're wrapping this up pretty soon. Okay, so that was my fault. It literally was perfect, and then I just was not paying attention. So here we have, and it does it in the order that you specify it. So notice that before the select was a little bit higher, and now it's below the actual like results because that's just where it is with the code that I ran. So it does it in order. So we know that our average rating is a 3.84, which is like, kind of good, not great. And then we also want to order it by rating, so we know what's the best. If I want to do by descending, I believe I just have to do that. And as you might have caught it quick, it will do the best rating. So now it tells you, buy that chair, buy that ottoman, buy that table, maybe skimp on the decor in the bed. So that's one easy way to use SQL, is basically you can set up the table that you want. You can enter in values. I can update these values if I want, and then I can, see what I can analyze it, basically see what information, what can I gather, what can I learn from what's in the table. All right, there's a queue. It's working. Yeah, yeah. I saw it. You said it's working. I didn't even see that it was working, so I was just looking at it like, why is this not working? This doesn't make any sense. All right, so let's do one more of the something similar to this. We're gonna do something a little bit harder, just to see some more capabilities of it. So this is a very simple way to kind of learn through this. And of course, this can be used in your own hack. So basically, one way that you could implement this is you can create this database on the side, and then you could connect it to whatever program or file that you're working with, and then you can connect the database to that, run the analysis, and then do like a back and forth. We're not going to be doing that. I'm not going to be writing separate code and trying to build a database, working strictly with SQL, but there is a lot of capabilities there. All right, so I'm going to stop sharing because I need to show a different screen, and we're going to do what challenge do I want to do next. So I have time for one more. We could, let's see, we could try doing this one. This one seems a little bit more spicy. I think I want to do this one. Yeah, we'll do this one. I'm not too worried. We'll do this one. So I'm going to share my screen, and we will do the very specific Chrome tab. Spin-offs, create table with multiple data types. That's what I want to do. We'll do this one. Here we go. Create table with multiple data types, which I think is actually pretty similar to the one we did before, but just wanted to continue with showing you more examples and just more ways for you to try to do this. If you're following along and you want to try doing this on your own, I highly recommend it. I'll give you all a minute to play with it if you want. So I'll read it out. Create table with multiple data types. So we've learned how to create a table from the go with this last project that we did. So when you create a table, you can specify different data types for the columns. In SQLite, there are various data that you can use. So we've covered this: integer, real, and a text. When a column isn't storing any value, it's null. And then there's something called a blob, which we will not use. And if you want to make sure it's never null, you can type not null in the create statement. And so SQLite does not have many data types like other SQL engines have. We talked about this. There are more approaches to adding more. So this is one way. I guess this is probably what I should have covered before, but that's okay. So I'm going to actually stop sharing that. I realize that's the exact same one that we had before. And we're going to do this last one here, which is... Here we go. So the challenge is grade book. We've created a database to track student grades with their name, number, grades, and what percent of activities they completed. In this first step, select all of the rows and display the name, number, grade, and percent completed, which you can compute by multiplying and rounding the fraction completed column. I don't see that database. Let me refresh. Was it supposed to be here? Let's go back. Oops, you don't know. You start over. Oops, yeah, please start over. Here we go. Okay, so this is what they have. So this has already been created for us. As you see, we're using a trusty Khan Academy to work through it. So they've created a table that has the ID, which is the primary key, the name of the student. They all start with W. Winston, Winifred, Winstein, Winsifer, and Winster, and Winstonia. Very, very creative names here. They have the number grade that they received, so 90s, 60s, 70s, 80s, and the fraction completed, I believe, for like the grade. And so we can select all the rows, display the name, number, grade, and percent completed, which you can compute by multiplying. Got it. All right. So the first thing I'll look at here, when I'm first off understanding how it's all set up. So there are 4 into student grades, number value. So yeah, okay. See, in this one they don't specify the ID at the beginning. I guess auto increment. That's what you need. So if you went back to the other example, I was talking about how, like, why is this ID why do I have to enter it in specifically? So you have to enter in this value called auto increment, which basically does the work for you. So notice here how there's only 3 values, but there are 4 columns. You don't need to do the ID because it's already there, basically. All right. So what's asking for, select all the rows and display the name, number, grade, and percent completed. Well, we don't have a percent completed. We have a fraction completed. So now this is a query within a multiplication, like analysis. So not only do I need to pull the data, I also need to manipulate the data while I'm pulling it. So the first things first is I need to select and show all of the rows. So easiest way to do that is I want you to select, I want to show all of them, and the name of this is called student grades. And you can see that from up here. So that's just showing, basically it's just showing what we kind of already know. We kind of already know that this was all here. And I'm going to do a separate line. Oops, I'm going to here, just so that people know that this is separate from the code that was already here. So we can see all the grades, but what they want is they just want to see very specific. They don't want to see the fraction completed. They want to see percent completed, which is basically multiplying and rounding the fraction completed and then, making it a percentage, which is multiplying it by 100 essentially. So with that, let's figure out based on what we learned. So we know that this asterisk shows all of the values, but we don't want to see all the values. We only want to see very specific ones from the table. So in order to do that, what I need to do is get rid of this, and I need to specify. So maybe I just want to see the name. So now it builds it off one by one, which is why I love this IDE. I want to see the name. I want to see the number grade. And then here's the tough part. So you want to see the percent completion, but you want to do it based off of the fraction completion. So there are several ways that you could do this. One way, which I'm not going to do, is you could just manually update this table and update the name of this column to be percent completed and do the work there. Or you can leave the table as it is, as it was created, and just manipulate it from down below. So one command that you can use that's asking to round, I believe there is a rounding command that allows us to do this. I'm going to double check quickly. I believe it's just called round. So as I mentioned, there's so many of these that we can use. And so I want wrong number of arguments to function round. So now we have this function. We basically need to round the values that I wanted. And so what I want to round is the fraction completed. That all rounded to 1. That's not what we want. We want to have this a percentage. So in order to make this a percentage, I need to multiply this by 100 because I'm going to just do this down here. So, get rid of that. In this comment over here, if we have 0.805, multiply that by 100, remove, so that will be 80.5. And you want it to be I don't need to put the percent here, but that's essentially what they're looking for. So basically, I want to take so this will go through every single column and do this, every single row and do this, which is nice. You don't have to, in other languages, you'd have to put in like a for loop and say, go through all of these. It just kind of does that for each column that kind of has this, each row that has this information. So fraction completed, I want to multiply this by 100, and this should be name, number, and percent completed. You sure are you sure your column names are correct? So this is another thing that we're going to go into. So now we have the information we want, but it's called round fraction completed times 100. That's not what we want. We want to call it percent completed, which is up here. In order to do that, there is a command called as, which basically means it allows you to rename the column name to something that's a bit cleaner. So in this case, they want it to be called percent completed, I believe. And rename number, they want to rename it to number. Okay, that's interesting. Maybe they don't care. Are you calling names? If your name number percent completed, why are you being? Oh, I spelled completed wrong. That's why. There we go. There we go. Okay, getting closer. You can do it. Thank you. So does that make sense? So this to clarify what we had done. We had basically, we didn't want to show the ID. So we completely ignored that and we just showed the name, the number grade that they had, and the percent that they've completed in the course. We didn't need to do anything for the name or the number grade. We just needed to pull those values. We wanted to take that fraction completed column, and first off, we had to rename it. So you do the as command to rename it to % completed. And then we also wanted to round it and to make it a percentage. So basically, we wanted to take that 0.805, multiply it by 100, make it into a percentage, and then round it. So 80.5, that will round up to 81. That's what happened here. And that was what the query had produced. So that's part one. Yay, we did it. And now we're going to go to the next step. And I'm going to look at the comments quick. Type 1 completed. Yes, thank you for yes. Somehow I make the most simplest mistakes, and I don't know how I'm missing them. All right, so I'm going to leave another set of comments here, another like line just to specify. So that was part A. I'm going to write that part A. And then next we have part B, which we'll read. Now this step is a little tricky. The goal is a table that shows how many students have earned which letter grade. You can output the letter grade by using case, which is a command that we haven't covered, but we will, with the number grade column, outputting A for grades, anything above a 90, B for anything above an 80, C for anything above a 70, and F otherwise. Then you can use the count and with group by to show the number of students for each of those grades. So that is a mouthful. That is a lot to do. So easiest way to do it is let's break it down into parts, and let's use these comments to help us kind of figure out the flow of what we want to do here. So first things first is we need to output the letter grade by using case. Case is very similar to how if you use it in Python. I guess this isn't multi-line. Is this multi-line? Yes. Okay, interesting. Okay, so these dashes are not multi-line. Like I said, that answers some question that somebody asked above. Is there's a difference between the two dashes and the more Java way to do it? Is that this is a multi-line way to write a comment. So the first step that we want to do here is we want to use case. So as we used Python before, or any language that has like that case way, it's very similar where you kind of list off the conditional. So you have your when conditional for when you're going to use it. The condition. And then so the way that SQL works is that you want to specify when this condition is met, do the thing, essentially, or then like assign it to whatever, basically, then whatever you want it to be. And so then you have multiple conditions, and then there's also like an else, essentially. I'll set this up, so no worries. So, and at the very end, when there's everything else, you want to set it as whatever you want to set it to. I guess it's like set it as blah, blah, blah. That's what we want. So that's set up for a case. So a lot of this really pulls from knowledge from previous like coding languages, and they just kind of reformat it a little bit for SQL. So that's that first part. Is essentially we want to kind of pull in, we want to output it. So we know that there's going to be a select in there somewhere. Somewhere in here, there's a select because we need to output those results onto this query result over here. We need to run the case to show based on the conditional, which they gave us a condition. So for A, we want it to be 90%, for B, anything above 80, and for C, 70, and then everything else is an F. So let's start with that. So what I want to do here is I want to select, and I want to go through every value in this table, essentially. And so for that, I am going to, and I also want to be able to, is asking for count to show the number of students for each of these grades. Let's not worry about that right now. We'll get to the count and the group by in a second. Let's just set up this case, and then we'll add where these other pieces should be in a second. There's a syntax error. Yes, I know. So for now, there'll be a syntax error on the side. I'm aware. We'll cover that in a second. So what's the first case? Well, first off, we need to specify that we have cases. So case is not that because that's Python. I don't think it is Python. I think that's just me being wrong, trying to enter in like the full colon. So basically, the first case that we have is when, as we specify, we need to specify when the case will be. I don't think it's space sensitive. So obviously Python is like a formatting. You have to use the tab, and then things like Java or C++ or any of those other more, other languages, you'd have to use these brackets. For SQL, that's not quite the case. It looks like it's space formatted. I don't know if like this space, I'm sorry, if this space means anything different than like this space. It might just be a formatting thing. So let's keep that in mind. So when the number grade is greater than 90%, we want to give them an A, which is great. Honestly, I wish the grading system was like that. I wish that the grading system was anything above 90% is an A. The A-, I think, is kind of rigged. A hot take. So basically, when our number grade, when it's greater than, you could do greater than or equal to, but in this case, that's not what they're asking for. So when it's greater than 90, we want to assign that to be A. And I guess we want it to be single quotes. I don't know if it matters, but we want it to be single quotes. And we can basically copy paste that information for A, B, and C, and just change that to 80% here, B, and then 70% C. And I don't believe we don't need to close off these off with semicolons, because remember, this is all part of a single query, so we don't need to like separate it. In this case, we did because of the comma, but we don't need to separate these individual lines here. And then, okay, so that basically when this happens, do all of that information. And then otherwise or else, I do want to make it an F. You could just basically do when number grade is anything less than, anything less than 16, anything less than like 69 or 70 and below, you can make it an F. You can do that, or you can just type an else. It just covers all the other cases, which in this case, all the other cases is an F. So I don't want that anymore. So then I think you have to end it. So this is another thing I have to then end as, I spelled that wrong. And so this is basically saying close this particular case here, and we want to rename it as letter grade. So let's review everything that just happened here. And I know the syntax isn't perfect, but just to review the content. So basically, we want to show the full table, and we want to reassign all the cases where the number grade falls within a specific percentage and rename them as the letter grade that we want. And so that's what this as is. So basically, we're renaming any of these we're renaming that column as the letter grade. And every time, for example, we see that Wincifer has a 66, we want to make sure that he gets an F, or she gets Wincifer. They get an F essentially. And so and we're renaming that column that has that information as the letter grade there. So from there, we want. And we're still selecting. So remember, all of this pieces are inside of this select. So we still need to specify the table. I know it seems a little bit redundant to have to specify the table that you're working with, because in this case, we're only working with one table. But when you get more complex and you're working with a lot more in SQL, you may be working with multiple tables, which is why it's important to specify the table, which is it's capitalized, which is student grades. All right, so let's see what we have so far. So I'm aware this isn't fully complete. There's still a couple of pieces missing, but what's printing out is the entire table that we're working with. We have the case that when the number grade is greater than 90, you get an A, and when it's less than, and the number grade is that new thing that we have here. So right here, and then otherwise showed as an A, B, C, or F. So let's just check it to make sure that it's correct. So it is a 90, and it's giving it a B. And that's because this is exclusive. So it's not saying 90 or greater. It's just basically anything above a 90. So that means an 89, I would say. If this was an 89, this would still be a B. But if it was a 91, it would be an A. So keep that in mind. I could do this and see how that changed this letter grade from a B to an A. So that's why there's that detail. Sometimes people may want to make it inclusive or exclusive. So keep that part in mind. And then everything else in an F. So I'm scanning this, and this all looks pretty good. We want to end it. We get a new letter grade. So the case essentially creates so this parses is creating a whole new column, and we're going to name it letter grade. So that's what this is doing. And we're getting it from the student grades. What we want to do now is we want to group them by the number of students with each of those letter grades, but we can't really do group by until we get the count. But let's try it. So it's group by. So that's a new command that we haven't done yet. So group by, and I want to group them by the letter grades because we have that information. And do I close it here? I don't think it does anything because, oh, here it is. So it does group it. Notice how it shows the groupings, but it doesn't show the counts of how many students are here. So this is kind of a bugging syntactical error where now we see the 3 letters. So basically they're grouping by the letter grade, but they're not showing us the aggregate count of how many students are in the letter grade, which is half of what we want. So we want it to be grouped, but we want to see the count. So maybe I don't want to see everybody's. I just want to see the overall count of what I'm doing, right? Here we go. I'm going to go back here. Guards. Base take. Typo uncompleted. Sorry, I'm just looking back at the comments here, making sure. Can you please show the Sql web page link for the hackathon challenge? Yes. Yeah, I can see that we're reaching the end here. Give me just a sec. See if I can pull. Okay, so I see the question there asking about the hackathon challenge. We're right at the end here. I'll grab that in just a second. Let's just wrap this up, and then we can kind of say our adieus. And so notice here now that it's actually showing the count. Now I can rename this something else if I want to. So maybe I want to do select count, and I want to rename this as like, I'll just call this count. But basically what it's doing is it's taking the count of each of the student grades. So it's seeing that, okay, there's 1A, 2 Bs, 3 Bs, 1 C, and 1 F, and you're grouping it by the letter grade. So rather than showing it by each person, it's grouping it by these grades. So now that you know that, you can see how many people earned what grade and how many of them done that. And that's what the group by does. It basically aggregates it, but you have to make sure that there's actually a number to aggregate, because without this, it was just showing the random numbers. Let me show you what it looked like before. Put the parentheses here. Yeah. So notice before it showed 4 of them because I think it just showed the top 4, or I guess it showed like the top ones after that, whatever. But that's essentially how you do that. So that's how that was a really complex one. And that was essentially the work of trying to break down how case works, how group by works, and making sure that you're setting up the schema, making sure that you have the right count. Because if we're grouping by and we want to have the count of them, we have to make sure that matches up here in the select. Whew, that was a mouthful. I'm going to go back to the chat. I'm going to stop sharing and go back here. And yeah, it's gotten much darker. Those 2 hours certainly have flown by. So that's essentially the end of the introduction to SQL. Hopefully that was helpful. Hopefully you learned something through that. The main goal of this workshop is really just to get a taste of what you can use SQL for. And if you've never touched it, some of the capabilities. As I mentioned on that site that I listed, there were a ton of different queries that you can run. It gets a lot more complicated than where we were going, but really just wanted to touch base on knowing how to do that, where SQL originates from, some of the tools that you can use, and how can you apply it into your own hacking skills. So I am the last. I'm going to go back to this question. Could you please share the web page link for the hackathon challenge? I am going to try to get that now. But yes, I'm going to pull that. If you're waiting for that link, I'm going to try to grab that link now. Otherwise, thank you. Hey, can you share a rough roadmap for resources for choosing SQL as a career? Yes, I can absolutely do that. Let me grab that right now. Otherwise, I'm going to just answer any last questions, but otherwise, that's the end. Thank you all so much for being here. First stream success, probably, maybe. We made it to the end, a little sweaty. But thank you so much for staying with me. I know that wasn't all perfect, but I appreciate it. But I'll answer a couple questions. So choosing SQL as a career. So this one thing to know, as I mentioned earlier, that typically if you're going down a career path that involves SQL, that may or may not involve working with R and Python, just because they tend to be the trifecta when it comes to analysis, unless you're focusing specifically on database specific work. So I'm going to pull out a few resources that I would look at, because I thought about going into SQL as a career. So I'm going to copy this. Thank you. So for that person who asked, here's one thing you can look at, and I'm going to pull another thing for you to consider. I don't have a very clear roadmap, but this one, it just kind of gives you some things to consider. So that first link, and then the second link is going to show you all the different career paths that you can follow while learning SQL. So I'm going to post that here as well. All right, did that post? It did. All right, and then so that's something you might want to look at and consider. And then last thing was the link for the hackathon challenge, which let me go and grab that. I think I know where it is. Checks for live stream. I don't believe, part of me is thinking, I don't know if we have I don't think there was a hackathon challenge specifically for SQL. I might be wrong on that, but let me double check here. I don't know if there's a link that we have. Forms, links, here we go. Is this what they're looking for? Move. Let me go back and was it this one? I might be wrong. That might not be the one. I will keep looking, and then if I happen to find the link, I will be sure to put that in the chat. And when it comes to this, because I know if you've all been here, you definitely want to get like your points for being here. Oh, I think it might be this one too. I'm going to open up this link. Join an online event and make sure that you get your points for that. It might be this one too. Otherwise, yeah, that's it. Thank you so much, everyone. I'm going to end this broadcast because we're reaching the end. I know there are a lot of other streams that are happening throughout the rest of the week. Please come and join them. I am going to be on another one on Thursday. That one's going to be figuring out how to work a difficult technology. So if you thought I was struggling now, you're going to see on Thursday, I'm going to grab a technology I've never used before, and you're just going to watch me on live stream, try to figure it out. So that might be fun. It might try to encourage those who are maybe, I want to try something new, but everyone else seems to be learning this technology faster than me, or I really want to show you the true raw process of working through a technology that you've never used before, and knowing that even if somebody has been coding for a while, it still might be challenging to them. So if you want to do that, that'll be Thursday, and so I'll be there, and then I might see you later on in the week. But otherwise, thank you all so much. Have a wonderful rest of your day or night, depending on your time, and I will see you again, and happy hacking. Ugh.